Now that we have looked at using Git on our own computer, it's time to look at how we can use Git and various remote Git services to share our work and to collaborate on projects. With this final video, you should finally be able to comfortably start using the group's Gitlab site. I'm quite sure that many of you will recognize the names of popular hosting platforms more than you recognize the name of the software Git. GitHub, for example, is an extremely popular website for developers to share their projects, and it is a staple of the open source community. Open source just means that the code behind the programs are shared publicly, and because of this, usually the software is also free to download. So oftentimes, you may have encountered links to GitHub to download certain software. If you didn't know anything about Git, you might even have assumed that GitHub and Git are the same. If you have spent any time on this website, you may have found the layout very counterintuitive. Why is the download button kind of hidden? And what is clone? Why are there so many weird options, and what does it all mean? Well, GitHub is, of course, a service made primarily for software developers and not casual users. And those developers are using Git. So on the website, they expect certain functionality that interfaces nicely with Git. This is why I wanted to explain the basics of Git first, before looking at hosting services like GitHub and Gitlab. So GitHub is just a place where people share their Git repositories. While GitHub is maybe the most popular, it certainly is not the only one. A competing service to GitHub is, for example, Bitbucket. I use Bitbucket for hosting my LaTeX publications and GitHub for my software projects, but there is no valid reason one needs to split it up like this. An important thing to recognize is that GitHub and Bitbucket are websites and services operated by companies. GitHub, for example, is now owned by Microsoft. The emphasis of the platform is public sharing. Originally, GitHub, for example, didn't even allow private repositories. When you uploaded your project to GitHub, it would be free for everyone in the world to download and contribute to. Now GitHub does allow private repositories, meaning that only you can see them when you log in, and only you can work on them. But still, one has to remain in good faith that Microsoft will not abuse your project, because you're essentially putting it on their platform and their servers. You might have similar reservations about uploading your code to GitHub, as a privacy-minded person is about uploading his pictures to Facebook. But since GitHub is still by far the most popular service for developers, if you want your project to get noticed by others, and if you want others to contribute to it, you're kind of locked into using it. Alternative to public services are hosting your own private Git server. Only you or a select group of other people, say people in an organization, have access to the service. GitLab and Git are examples of programs that will run Git server services on a computer. And just like GitHub, they offer similar web interfaces to the user to interact with the service. So for all practical purposes, for developers and teams, GitHub and GitHub are identical. But the difference is that the data stays on computers you control, and you have much more control over access rights as well. Both Git and GitLab are open source software themselves. You can install GitLab or Git on a computer in your house or at your place of work and set this computer up as a personal or organization level Git server. I have done this personally with a Raspberry Pi computer in my room, which is running Git, so I can upload my own Git projects to my Raspberry Pi, and each device connected to my Wi-Fi in my house can download these projects again. Anyway, GWDG offers access to servers running GitLab. This is the service we will be using for sharing our code within our group, and the one I will use for the demonstrations in this video. The advantage is that everything stays within our group and no one else has access. In addition, the code is safe from the claws of Microsoft, and we hope that GWDG is a trustworthy actor. But we don't have to deal with any of the server maintenance, which we would have to deal with if we hosted GitLab ourselves. However, if you are building a project that you think would benefit from public access or easier sharing with external collaborators, you should consider GitHub or Bitbucket. I don't show them in this video, but they are pretty much identical to GitLab. So once you understand GitLab, it won't be hard to use other Git hosting services. So how does it work? Well, actually on the basic level is very simple. Suppose someone has started a project which he is tracking with Git. He might want to make this available to everyone else in the team. He might also want to back up his project safely on another computer. But both these things can be achieved by pushing his project to a so-called remote. It's just a repository that was initialized on the Gitlab website. What happens is that a copy is made of the .git directory from the local computer to the Gitlab server. Now suppose we have two other people in the team that either want to use or work on this project. They also have Git installed on their computer. So they call git clone, which will make a copy of the .git folder on their computer. It will also by default create the working directory according to the master branch pointer. So basically git checkout master is automatically called, and there will be editable files in the folder. The important thing now is that everyone has an exact copy of the complete history of the project. Collaborator 2 can go and check out all of the previous commits that Collaborator 1 made. If Collaborator 1 deletes the project on his computer, or his computer dies, the project and the complete history survive. Even if the GitLab server dies, if someone else still has the clone project on their computer, it can be perfectly recreated on another server. I hope you can see that in this way, Git projects are extremely resilient to loss of data. Anyway, now that everyone has a copy of the repository, all of these people could start contributing to it. They make changes and commits in their local repository, and when they are satisfied with that, they can upload the changes by pushing them to the remote with git push. When people add commits to the remote repository, others can update their local repositories with the additions using git fetch and git pull. This is how everyone can stay in sync, everyone can contribute, and everyone makes changes and works on their own computer without needing network access anyway. So let's demonstrate the first part, related to pushing and cloning in practice. We'll also look very briefly at the GitLab interface itself. Here we see the GitLab site. You can navigate to the repositories you have access to by clicking on projects. All of you should now be part of the group MPIE ATEM. At the time of recording, we just have the test repository in there, which all of you have access to. We could create a new remote repository by clicking New Project here, but for this simple demonstration, I will just make a personal project to which only I have access. I'll go to my own projects, which include all the projects in the MPIE ATEM group, and create a new project here. Let's call the project Demonstration. Notice that this project will be hosted in a location linked to my user account. I could also select the MPIE ATEM group here in the drop-down box. We'll give the project a short description. Notice that I can choose to make this a private project, to which only I will have access. If a private project is created in a group, then all the members in the group automatically get access. Alternatively, we can make a project internal, which means that everyone with an account on the GBDG GitLab site can see it. But since this is not only MPIE people, one might as well make the project completely public. Notice that you can create a new repository with a README file, in which case the remote repository will already have a commit with a text file. The README file is special. You create it with Markdown syntax, and GitLab or GitHub will automatically render this text with the correct formatting when you view the project. In the README file, you should describe the project and say how people should use it. If you already have a project you started locally, and now you want to upload it, best not to create a README file here and instead add it manually to your local folder. But you might also create the remote repository first before you do anything locally. And in this case, you might already want a few files to be initiated in the initial commit. So let's now create our project. As you can see, GitLab already gives you some instructions. You can go over these yourself. Normally, you will already recognize many of these commands. What we want to do is the fourth option, adding an existing repository. But when I recorded this, I didn't see that, so we will instead follow the third option. We already have our Git repository in our folder, so we don't need to do git init. What we have to do is tell our local Git repository to connect to a remote repository. We will do this with the git remote add command. Then you type the name you want to give the remote and then the URL. Origin is the name or alias of the remote. is so we don't have to type this long URL every time we want to connect to the server. You can change this name into any other name that you want in this command, really. The reason people often leave it at origin is the following. We will see that when you clone a repository, Git already automatically assigns the URL you clone from to the name origin. If your project is hosted on only one remote, then it's just convenient to name the remote origin. But maybe you host your project both on GitLab and GitHub. In this case, you have to distinguish your two remotes with different names. Okay. Nothing has really changed, and there is no output. With git status, we can see that our working directory is clean. So we skip the next steps of adding files to the index and committing, and then finally, to upload our repository to the remote, we just execute git push. What this command means is we will push to remote origin, and we will push the master branch. The -u modifier stands for the -set upstream. The reason you add this is because pull commands become easier in this way. I've added a link to a stackexchange thread related to this in the description of this video, and we will see what pull does later. We see that now I am being prompted whether I want to continue connecting, and I will say yes. Now, because I have set up SSH access to the server, I don't have to enter any credentials. If you have not set up SSH access, you may be prompted for your login to the GitLab site at this point. To set up SSH, I refer you to the README I've created in our test repository. And it looks like the push was successful. We can verify this by refreshing the page. And now we see the two files we had in our repository here. Our remote repository is now operational. We can see that the contents of file 1 and file 2 are the same as we had in our computer. You can see that we can switch the branches directly here in the drop-down menu. At this time, you see that there's only the master branch. Where is our BR2 branch that we had? Well, from our last commit, we only pushed the master branch. And this illustrates an important point. The pointers on our local machine are not necessarily the same as the remote pointers. So what is actually happening is that we have now a remote Git repository, and it has its own master branch called origin/master. And whenever we make changes locally to our master branch, and then we push, by default this gets merged into the remote master branch. Most of the time, this is just a fast-forward merge. New commits get added onto the chain, and origin master is moved along the chain. If we want to copy all local pointers to the remote, we push with the modifier --all. We don't need to add origin because we only have one remote, so it's a bit easier like this. You can see BR2 was copied to the BR2 branch on the remote. You can see that if we refresh the page, now the BR2 branch is available in the dropdown. If we select it, we will see how the working directory looks at this commit. If we check file 2, now we see yellow star instead of pink heart. Okay, now we will briefly check out some features on the GitLab site. Although there are tons of options, you will most likely never use them. In fact, I don't even know what half of the features are for, to be honest. The most important features are, of course, the download and clone buttons. With the download button, here you will download the files as you currently see them on the page. The zip file that you download will not contain the full Git repository. Effectively, you will just be downloading the files in one commit. This is not the good way generally to do things because it will be difficult to update to new versions. Even if you will just be a casual user who will not be adding to the code, I recommend you always clone the repository. You see here are two options for cloning, with SSH and HTTPS. For SSH access, you need to generate a key pair and upload the public key to your account. Again, look at some other resources for how to do this. But anyone could clone with HTTPS, so use this link and you may have to enter your credentials in your terminal. We can also check the history of the project here by clicking on the History button. You can see all the commits listed here, similar to what we get when we type git log. In each commit, you can go and browse the files. You can explore the branches, but in this case, we will only see the master branch because this was recorded when I hadn't merged the BR2 branch on there already. I haven't talked about tags at all, but they are another type of pointer just like branches. The difference is that branch pointers move along a chain, while tags stay stuck to a specific commit. For example, if you consider a particular commit to be a certain version, you can add a version tag to this commit to find it back more easily. You can see some fun statistics about commits and so forth also, but of course for this repository it's pretty bland. Graph plots the same structure as git log with the -- graph modifier. You can see, however, that the BR2 branch pointer is not there. After I pushed all the branches, the graph looks like this, and BR2 is there. Anyway, we can click on a node to see information about the commit. We could also compare different Git commits, which is identical to Git diff. Once you start getting more sophisticated, you might start using issue trackers and merge requests. Issues are a place for people to report bugs, things to do, ideas, whatever. It's basically a bulletin board for the project, reminding people what the tasks are. Merge requests are for when people make commits to branches that they don't actually have write access to. Okay, now let's look at git clone and pull and an example of collaboration. Here I've created two folders which will represent two collaborators on the project, Bert and Susie. Of course, this is all still happening on my computer, so all commits are being made by Niels. But still, it's a simulation of how it would go if multiple people working on different computers would collaborate on the same Git project. So here we are in Bert's folder. Bert has a blue face. Bert wants to start working on the project, so he goes to the Gitlab site, he copies the repository with the HTTPS clone link. He opens the terminal and navigates to the right folder where he wants the project to go and just enters git clone and the URL. You can see that the demonstration folder has appeared in the folder. By default, clone will put the repository in a folder with the same name as the name of the online repository. Now with the terminal, we cd into this demonstration folder to start working there. And I'll also click it open here so we can watch what happens as we type the commands. You can see that our two files are there, as well as the .git folder. If we check git log, we see that our full history of the project is there, and that the last commit on the master branch is checked out. We also see now these extra red pointers. So when you clone or pull from a remote, this also copies the remote branch pointers. So we can see at which state the branches on the remote are. Now this does not update real time. If someone else makes a change by pushing to the remote, you can only update the remote pointers on your local machine by downloading the changes with fetch or pull. The origin head pointer is a bit of a special one. It denotes which branch on the remote is automatically checked out on clone and which branch you see by default when you open the web page. Usually, this points to the master branch. Bert cloned after I pushed all the changes and all the branches, so he also sees the origin/br2 pointer. Now Bert decides he wants to add a new file to the project, so he creates file 3. He goes in there and adds some crazy text because Bert is a bit wacky. He saves, adds the changes to the index, and commits. Now when he checks the log, his local master and head pointer have moved up the chain of commits, but the remote pointers stay behind. To update the remote with the changes, Bert pushes them to the origin master. Now if he checks the logs again, the origin master and origin head have been updated. Pretty much what happened is a fast-forward merge of the remote branch and the local branch. Upon refreshing the GitLab page, file 3 is now present in the repository, and it contains the text Bert added. Now let's go into Susie's folder. Susie has a green face. She cloned the repository already a while ago. As you can see, file 3 is not present. Lucy also goes to the terminal and checks that she is in the right folder with pwd. She also checks git log. Her local master branch as well as her remote pointers are outdated. In fact, you see she doesn't even have the origin/br2 branch because she cloned before I pushed all the branches. Comparing to Bert's log, she is behind 1 commit. Because Susie realizes it's been a while since she updated her local repository, she decides to pull down all the changes with git pull --all. File 3 appeared in the working directory, and now if she checks git log, she can see Bert's addition. In addition, all of the pointers on the remote have been downloaded. Susie decides that Bert's addition is not very good, so she decides to fix it up a bit. She adds some extra text to file 3 and saves. However, at the same time, Bert is working on his computer and he also finds he wants to make another change to file 3. Bert is a bit of a prick, but he's fast. Bert is done with his changes faster than Susie. He immediately decides to commit and push his changes. So he follows the same procedure as before and in between checks what is happening with git log. There, Bert has pushed his changes, and when he refreshes the GitLab site, he sees that his changes have taken effect. Now let's go back to Susie. Susie had made changes to file 3 on the same line as Bert, but she hasn't committed or pushed her changes because she is more diligent. But now she is satisfied and adds her changes to the index and commits. Susie checks git log, and since she doesn't know about Bert's last changes, she thinks she is ahead of the remote and ready to update by pushing her changes. However, she gets an error when she tries to push, and Git warns her that since her last pull, work has been added to the remote. Before she can push, she has to integrate the changes into her local repository. So she calls git pull. Now git pull is actually 2 commands in one. Git fetch followed by git merge. Basically, git fetch just collects the remote branches, and you have to merge the changes manually, while git pull will try to merge the remote changes into the local branch and update the working directory. So when Susie calls git pull, she gets a merge error. The addition she made to file 3 conflicts with the one that Bert already pushed. So Git was unable to make a merge commit. Susie has to resolve the merge conflict and then commit. You can see that Git indicates the line in the file where there is a conflict. Susie checks Bert's work but thinks her addition is better, so she fixes the file. She commits her changes, and if she checks the log, she sees that the edits from the remote have been merged into her local master branch. Now the remote master branch can be fast-forwarded with git push without any problem. Git log verifies that the push was successful. Also, on the GitLab site, the updates were successfully integrated. Finally, I want to say something about how I propose we work on projects on our GitLab site. I suggest each repository gets at least 2 branches, which are on the same chain, development and master. Origin master will be there by default, of course. To add origin development, there are numerous ways of adding a remote pointer, one of the easiest being just creating a local development branch and pushing it to the remote. For the casual user, those of us who are sure they will not contribute to any code, they just have to know the git clone and git pull commands. They pull down the repository master branch and just work with it, never changing anything in the scripts. The origin master branch is supposed to be a stable version, something not without bugs and errors, but something people could just use more or less in an expected way. When the master branch is updated, the casual user just has to pull down the changes and his scripts or program are updated. Then there are those of us who wish to add and contribute to some of the projects. They are the developers. They may also wish to just use the code in the master branch for their work, but they also want to tinker with it to make it better. Basically, they can do whatever they want within their own repository, making commits, making local branches, whatever they think is necessary to make the code better. I do always recommend keeping your local master branch clean and doing experimentation in sacrificial branches, which you can merge and delete later if you're happy. If the developer just wants to use the stable version of the code, he can always check out the origin/master branch. The only thing people cannot do is push to the origin master branch. I have locked this for almost everyone. At this time, everyone in the lab has the developer role. That means everyone can push to unprotected remote branches of any project. But it also means that everyone can push their changes to the origin development branch, and in this way advance the project. You can also push to any other branch you wish to create, but let's keep it simple on the remotes. The origin master branch is sacred and locked, however, because we want the casual user to be able to rely on stable scripts. The more adventurous user can always pull down and use an experimental branch. But only the owners or maintainers get to decide that the development branch looks acceptable, and if so, they will fast forward the origin master branch pointer to a new version. Who gets to be the owner or maintainer will certainly evolve and be decided in the future. Currently, it's just me and the group leader. If you do try to push the master branch to the master branch, this will arrive as a merge request in one of the owner's accounts. Currently, I am an owner and I don't feel like looking over and accepting a bunch of merge requests, especially not for trivial changes to the test repository. So I will ignore and delete all of them. Please push your changes to the development branch if you have commits to share. At some point, the owner will decide to merge the master branch with the development branch. I hope this gives you a feel for how working with Git and Gitlab can allow us to work together on various types of projects. You might say that collaborating on Google Docs or via file on the cloud is easier. That might be for some cases, but the big advantage of Git is that all changes that were committed are somewhere saved in its history, so data loss is nearly impossible. Overwriting each other's data is also impossible, since one has to consciously address merge conflicts. Working with your project in Git requires a bit of different mindset, but once you know the most important commands, it can become second nature. I hope we can have a fruitful collaboration on our GitLab site. Thanks for watching.